Okay, so one of the last things that we need to tackle with functions is to look at inverse functions. So hopefully you've tried the Heggerty Maths task where it shows you how to do that using sort of the idea of inverse operations. I'm going to recap that in the first couple of examples here, but also show you a different method, and a method that is really useful, really helpful when it gets to more complicated functions. So first one, nice simple function. We've got 4x minus 5. So if I started off with my x, what's happening to that? It's being multiplied by 4. So I get 4x, and then I'm subtracting 5 to get 4x minus 5. So to get my inverse function, I'm going to do the opposite operations in the opposite order. Instead of subtracting 5, I'm adding 5. Instead of multiplying by 4, I'm dividing by 4. So x plus 5 is x plus 5, dividing by 4, x plus 5 over 4. So the inverse function of f, so the f minus 1 of x, is x plus 5 divided by 4. Okay, and that might be the easiest way that we have to do that, but there is another method. The reason why we need to know the other method is because this will not always work. So particularly this doesn't work if we get a function. Well, it's harder if we get a function where x is on the denominator, but it doesn't work at all if we get a function where this x, or our variable, whatever our dummy variable is, appears twice. Because then we can't just take our dummy variable and see what happens to it, because it's appearing in two different places. So I'm going to talk through using this same example so we can contrast the methods and see we get the same answer. I'm going to talk through the other method. And the other method is to sort of think of this like a graph. So think of it as y is equal to 4x minus 5. And what we're doing, we've got values of x, and we're plotting them to y. So our function is taking x values to y values. Okay, and if you imagine the graph here, it would have a y-intercept of negative 5. The graph would look something like that. So that is my graph, y equals 4x minus 5. Okay, and what we essentially want to do the inverse function, we want to go back the other way. So rather than taking our x's and going to y's, we want to go back the other way. We want to see, well, how do I get from my y to my x? So I want to make x the subject. So using that work we did on rearranging. So let's add 5 to both sides. Y plus 5 is 4x. Divide both sides by 4. You get x is y plus 5 over 4. Okay, so the inverse, bearing in mind I'm starting with y here, this is a function of y, this x is a function of y, so f inverse of y is y plus 5 over 4. Because that's a dummy variable, I can just write it with x instead. So f inverse of x is x plus 5 over 4. There's not a difference between what I've written down there. We can really use any letter we want. Usually we would use x, and we use the same dummy variable that we've been given in the question. So that's why I've replaced that there. And the reason why I drew this graph was just to demonstrate, if we have the line y equals x here, basically this x plus 5 over 4, if I would look like that, would be a reflection in the line y equals x. And if you plot, so you use maybe a website like desmos.com to plot the original graphs here, so y equals 4x minus 5, and the inverse functions, y equals x plus 5 over 4, you'll see that they are always reflections in this line y equals x, because essentially what we're doing is swapping the x and y coordinates around. So in my original function, I'm taking x to y. My inverse function is working out how to go back the other way to get the y back to x, and then just relabeling. Okay, for these examples, just so I'm not going over the same ground you should have looked at yesterday, if you haven't, So if you're not familiar with this idea of using the sort of the function machine idea, do go on Heggerty Maths and check that. But I'm presuming that you're fine with this method, so I'm just going to practice this method. So same starting point, y is 8x minus 3 over 7. Okay, that tells me how to get from x to y. I want to find the inverse. I want to find out how to get from y to x, so I want to make x the subject. We'll start off by multiplying both sides by 7, so we get 7y is 8x minus 3. Add 3 to both sides. 7y plus 3 is 8x. Divide both sides by 8. X is 7y plus 3 over 8. So f inverse of y would be 7y plus 3 over 8. So how would I get x from y? I'd do 7y as a function in terms of y. I'd do 7y plus 3 over 8. But of course we said we generally give that in terms of x, so f inverse x is 7x plus 3 over 8. Okay, so let's have a look at a couple more examples. Fx is the square root of x plus 4 over 5. Exactly the same ideas. So we start off with y is equal to square root of x plus 4 over 5. And graphically what I'm trying to do is flip this graph in the line y equals x, swap the x and y coordinates around. So I want to make x the subject. Well, get rid of that square root by squaring both sides. So y squared is x plus 4 over 5. So multiply both sides by 5. So 5y squared is x plus 4. Okay, let's take away 4 from both sides. So we get x is 5y squared minus 4. So how do I, as a function of y, in terms of y, go backwards, do the opposite steps? I do 5y squared minus 4. So f inverse of x is 5x squared minus 4. I'm going through this very quickly, but the reason why I'm going through it very quickly is because we should have already practiced all of these steps before. This rearranging we've done. Okay, so it shouldn't be an issue for us. All we're doing is changing this f of x, or whatever function we're given. It might not always be f, it has been in all of my questions. Whatever function we're given to y, rearranging it, and then replacing the variable at the end. Okay, 2 more examples to look at. So this is an example now where you couldn't do it by the function machine method. The other examples I've looked at, you could, and you can test that out. These you can't. If you did the rearranging equations lesson last week, this shouldn't be too much of a shock. The steps in this should be familiar to you. Okay, so y is 2x minus 6 over 6x minus 4. I need to multiply both sides by 6x minus 4 to get, hopefully my pen will keep working for the rest of this video, to get rid of this 6 minus 4 by from the denominator here. Again, we can think of that as over 1, like we did in the rearranging equations video if it helps. So on this side, the 6x minus 4's cancel out. We're just left with 2x minus 6. So we're dividing by 6x minus 4, then multiplying by 6x minus 4. On this side, we've got 6x y minus 4y, and I want to make x the subject. Remember here. Okay. So what I'm going to do next is get all the x's over to this side. So let's take 2x from both sides. So I've got 6xy minus 2x minus 4y is equal to negative 6. I don't want this 4y over here. That's not in terms of x. So let's add 4y to both sides. You get 6xy minus 2x is equal to 4y minus 6. I only want the x written once, so let's factorize that. You get x lots of 6y minus 2 is equal to 4y minus 6. And dividing both sides by 6y minus 2, we get x is 4y minus 6 over 6y minus 2. So to get back from f to do the opposite steps, in terms of y, we do 4y minus 6 over 6y minus 2. So f inverse of x is 4x minus 6 over 6x minus 2. Okay, remember, it doesn't really matter what letter I'm using here. This is just a dummy variable. Okay, it matters in the sense of picturing that graph that I drew on the first page, but in defining my function, as long as I'm using my variable consistently on the line, then it's absolutely fine. Okay, one more example. Maybe try and pause the video, have a go at it. Y is 5x plus 5 over 2x plus 6. Okay, I want to get rid of this from the denominator. And I'm going through this super quick because I did loads of examples on this last week in rearranging equations. So if you're struggling here, go back to that and look at that. It's probably that you didn't spend long enough on that. Okay, I've got 2xy plus 6y is 5x plus 5. I want all my x's on one side, everything else on the other. So let's take 5x away from both sides. 2xy minus 5x plus 6y is equal to 5. Okay, let's get rid of that 6y. I don't want that over that side because it's not one of my x's. So now I've got 5 minus 6y on my right hand side, and on my left hand side my x terms 2xy minus 5x. Got the x's written twice, so I need to factorize. X bracket 2y minus 5 is equal to 5 minus 6y. And now just to get the x on its own, we divide, let's push that up a bit, both sides by 2y minus 5. So we get that x is equal to 5 minus 6y over 2y minus 5. So that means f inverse of y is 5 minus 6y over 2y minus 5. My function was given in terms of x, so I want to give the inverse in terms of x. So f inverse of x is 5 minus 6x over 2x minus 5. Okay, and that idea of swapping those variables around, again, shouldn't be shocking or difficult for us if we followed the composite functions lesson from yesterday. Okay, hopefully that made sense. Again, I know it was very fast, but it is all things that we have done before, just bringing them all together. It's the hardest things we've done before, so don't worry if you struggle. Don't worry if you find it hard. Keep watching the video, keep trying the questions, and ask me any questions if you get stuck. Thank you.